So I estimated, using that methodology, estimated about 2.5 to 25 million tons of oil could potentially be on these wrecks. And that was something of concern because they could potentially leak out.
For decades, the silent steel tombs resting deep beneath the ocean's surface were assumed to be relics of a forgotten Cold War, sealed away and harmless. But what if these wrecks are far from dormant? Recent explorations have uncovered radioactive plumes thousands of times stronger than expected, leaking deadly toxins into some of the world's richest fishing grounds. Could this be the beginning of an environmental catastrophe no one saw coming? And beyond the radiation, some of these sunken vessels hold secrets that challenge everything we thought we knew about Cold War espionage and power. What lies beneath will change how we see the ocean and our own future. A toxic time bomb beneath the waves. Beneath the icy waves of the world's oceans lie dozens of Soviet submarine wrecks, long thought to be silent relics of a bygone era. These steel giants were once symbols of military power, but have since become forgotten underwater tombs. For years, it was assumed that these vessels, sunk decades ago, posed little more than a rusting problem. Yet, recent investigations tell a far darker story, one involving radioactive contamination seeping slowly but steadily into the ocean. Despite their isolation on the ocean floor, these wrecks are far from inert. Under pressure from saltwater and corrosion, critical components are breaking down, allowing dangerous materials to escape. The real surprise came when remote-operated vehicles captured footage revealing active plumes of radiation escaping from the hulls. Sensors recorded levels millions of times higher than normal seawater, a figure that stunned scientists and environmentalists alike. Such radiation is not just a remote underwater issue. It has implications for marine life and human communities nearby. What makes these underwater sites so alarming is more than just the presence of radiation. Many of these submarines still contain nuclear reactors and torpedoes, armed with plutonium, one of the deadliest substances on Earth. Plutonium has an unbelievably long half-life, lasting tens of thousands of years, meaning these wrecks will remain hazardous long after any immediate cleanup is done. The release of even small amounts into the marine ecosystem can have widespread effects, contaminating the food chain from plankton all the way up to large fish consumed by people. While some say the deep, cold ocean waters slow the breakdown and spread of radioactive materials, recent measurements tell a different story. Currents are actively pulling contaminants out in intermittent bursts, creating radioactive smoke rising from rusted ventilation pipes. This unexpected and ongoing leakage challenges previous assumptions of stability and raises urgent questions about how much has already spread unseen. The gravity of these revelations shifted the scientific conversation from watching and waiting to demanding action. Even more troubling is the scale of the problem scattered across vast oceanic regions. What was once dismissed as a handful of isolated incidents now looks like a growing crisis, with multiple hotspots leaking radiation. Official responses have historically downplayed these dangers, but the evidence captured on video and through sensor data refuses to be ignored. These wrecks are no longer just Cold War history. They are active pollution sources inching steadily towards environmental disaster. Yet, what exactly has caused these leaks remains partly shrouded in mystery. For decades, little to no inspection or maintenance has been done, and the effects of decades underwater have taken a toll no one fully anticipated. This was not just neglect. Some suspect that secret experimental technologies and Cold War-era gambles might have turned these vessels into ticking time bombs. As investigations press further, the full scope of damage, both physical and political, is only beginning to come into focus. One chilling aspect is the hidden nature of these dangers. Unlike a nuclear disaster on land, these underwater wrecks are out of sight, and therefore out of mind for most people. This detachment has made it easy for governments and industries to avoid accountability for years. But the ocean is not a limitless dumping ground, and the creeping spread of radioactive elements threatens to shatter this illusion of safety. The question now is no longer if these wrecks are dangerous, but how rapidly their damage is spreading. Scientists are racing to measure contamination, track currents, and understand which areas are most at risk. Emerging data suggests that the problem may have already begun to affect fisheries, coastal environments, and human populations dependent on these waters. The legacy of Cold War secrets is not confined to history. It is washing onto shores every day. These initial alarming discoveries are just the beginning. One wreck in particular, located deep in the Norwegian Sea, has become the focal point of this underwater investigation and the symbol of what could be a much larger catastrophe. It's a story that blurs the lines between Cold War tragedy and environmental emergency. What happened there will shape how we view all the other forgotten wrecks resting in the sea. As the ocean reveals more of its buried secrets, it's clear that the damage beneath the surface demands urgent attention and new understanding. This dangerous legacy raises uncomfortable questions about what else lies hidden out of sight and what it could mean for the future of our oceans. The mysterious K-278 Komsomolets disaster. On April 7, 1989, the Soviet Northern Fleet's pride, the K-278 Komsomolets, faced a sudden crisis deep beneath the Norwegian Sea. This was no ordinary submarine. It was unique, crafted with a titanium hull that allowed it to dive deeper than any American vessel at over 3,000 feet. As a one-of-a-kind prototype, the Komsomolets represented cutting-edge Soviet naval technology and stealth. But that day, a fire erupted in the rear compartment, turning the impressive vessel into a death trap. The official explanation pointed to an electrical short as the spark that ignited the blaze. Yet, skepticism has lingered ever since. Some experts suspect the sub was testing a secret, unstable weapon, perhaps a torpedo fueled by a radical new compound prone to ignition. Others propose the fire resulted from a covert collision with Western hunter submarines that shadowed Komsomolets during its record-setting missions. In the cold and dark expanse of the deep ocean, such a battle could have gone unseen, but with deadly consequences. Once the fire started, the situation deteriorated rapidly. Electrical failures disabled essential systems, including the ballast tanks needed for controlling buoyancy. The crew fought against the flames in freezing conditions for 6 grueling hours before surfacing, but the damage was irreversible. The proud submarine eventually sank to a grave nearly 5,500 feet deep, leaving 42 of its 70 crew members lost to the deep. It was a Cold War tragedy, wrapped in secrecy and speculation. What makes the Komsomolets more than just a sunken submarine is its deadly cargo. It held a nuclear reactor rated at 190 megawatts, still intact but submerged miles beneath the surface. Even more dangerous were 2 nuclear torpedoes on board, each loaded with about 28 pounds of plutonium. Unlike uranium, plutonium is incredibly toxic and has a half-life measured in tens of thousands of years. This meant a lethal hazard now sat quietly decaying on the ocean floor, a radioactive enigma under crushing pressure. For years, experts believed that the extreme depth and cold water would contain any leaks indefinitely. But in 2019, a joint Norwegian-Russian expedition turned that belief on its head. Using robotic submersibles, they recorded footage that exposed corroded titanium sections leaking a cloudy, radioactive plume from ventilation pipes. Sensors on board measured radiation levels up to 1 million times higher than the surrounding seawater, an unfathomable spike with grave implications. The plume's main radioactive culprit was cesium-137, the same isotope that devastated areas around Chernobyl. Cesium-137 follows the ocean currents, entering small plankton and climbing the food chain to fish consumed by humans. This discovery proved the wreck was neither stable nor sealed, but actively polluting the surrounding waters. The slow breakdown of the titanium hull and the expansive damage from decades underwater have transformed Komsomolets into a ticking environmental time bomb. Theories about this leak reveal the murky intersection of wartime secrecy and environmental tragedy. Some whisper about red mercury, a mythical Cold War substance once rumored to act as a trigger for nuclear devices. While many dismiss it as myth, it could explain the unexpected chemical reactions intensifying the corrosion and radiation leaks. If true, it paints a disturbing picture of experimental technology left to decay in the ocean's depths. The Komsomolets tragedy redefined how the world viewed underwater nuclear wrecks. It transformed public perception from passive historical sites to active sources of pollution and risk. The discovery prompted urgent questions about other submarines scattered across the Arctic and Pacific Oceans. Wrecks many believed were safe decades ago, but might now be deteriorating in silence. Despite its somber origin, the Komsomolets is only the opening chapter in a broader, more alarming story of Soviet-era nuclear debris. Hidden beneath the ice and waves, a nuclear graveyard awaits discovery, threatening environmental disaster on a scale still difficult to grasp. From these chilling depths, the Arctic's nuclear graveyard emerges with dark secrets yet to be fully understood. Arctic's nuclear graveyard and hidden threats. The Arctic region, once the strategic heart of the Soviet Northern Fleet, now serves as an ominous underwater cemetery for nuclear technology. During the Cold War, this frigid expanse became a dumping ground for radioactive waste and decommissioned vessels, many of which remain submerged beneath icy waters. Officially, the Soviets admit to sinking 19 ships loaded with radioactive materials. But reports suggest the scale of dumping goes far beyond that number. Alongside sunken ships, approximately 17,000 containers of radioactive waste were deliberately discarded in Arctic seas. Even more alarming, 16 nuclear reactors, many still fueled with spent nuclear material, were dumped, raising the question, how risky are these relics now? One notorious example is the reactor from the K-27, an early Soviet sub featuring a liquid metal-cooled reactor. Its design was flawed and dangerously unstable, earning it the grim nickname, the Golden Fish, among its troubled crew. In 1968, the K-27 suffered a catastrophic accident that released radiation and injured crew members. After years of attempts to repair it, the Soviet Navy chose a desperate solution in 1982. They towed the entire submarine to a shallow, isolated bay called Keros and sank it intentionally, with around 800 pounds of highly enriched uranium still inside. The official story cites cost and danger as reasons, but darker theories suggest they hoped to bury a volatile disaster out of sight. The risk with these shallow water dump sites is acute. Unlike deep ocean trenches, where high pressure and low temperatures slow chemical reactions, places like Keros Bay are exposed to storms and shifting sediments. Experts warn that the K-27 could reignite a critical nuclear reaction underwater, potentially causing a massive explosion akin to an underwater Chernobyl. This looming threat keeps scientists uneasy about what lies just beneath the waves. Fast forward to 2003, when the Cold War was over, but its legacy was far from resolved. The K-159, another nuclear-powered submarine, had been retired for 14 years and was awaiting dismantlement. Despite containing roughly 800 kilograms, nearly a ton, of spent nuclear fuel, plans to tow it across the Barents Sea in the middle of a storm were authorized. This reckless decision resulted in the submarine sinking once again, taking 9 of the 10 crewmen on board with it. Many view the K-159 sinking as criminal negligence, but there's a more cynical explanation circulating. Russia was being paid by international partners to dismantle aging submarines, but some believe the cost of dismantling K-159 was too high. The theory is that sinking it was a covert way to make the problem disappear from sight, while still collecting cleanup funds. Whether accident or deliberate, the submarine became yet another toxic wreck polluting Arctic waters. Together, these incidents expose a sprawling underwater graveyard of nuclear material, much of it poorly contained and aging badly. The combined radioactive content in just these 3 wrecks, Komsomolets, K-27, and K-159, is greater than all other radioactive waste ever dumped in oceans worldwide. In the unforgiving Arctic environment, the ticking clocks embedded in these relics grow louder every year. From the icy silence of the Arctic waste sites, attention now shifts to a very different kind of Cold War relic, one showing decay on a wider scale and in a more populated region. The rusting ghost fleet of Vladivostok. Along the quiet coasts near Vladivostok, Russia's main Pacific naval port, appearances deceive. The waters seem untroubled, peaceful even, but lying just beneath the surface is a sprawling graveyard of rusting submarines. This ghost fleet is a collection of dozens, possibly over 100, decommissioned Soviet nuclear submarines left to decay in shallow bays. After the Soviet Union collapsed in 1991, funding to properly scrap and dismantle them vanished, leaving these hulks to slowly erode in saltwater. Many of these submarines were nuclear-powered, and their decommissioning was far from straightforward. Safely removing and storing spent nuclear fuel rods is a complex, costly, and dangerous process. The economic chaos of the 1990s brought a halt to almost all of this critical work. As a result, many of these submarines still have their reactors intact, with spent fuel corroding inside. Some lie half-submerged, their conning towers jutting at odd angles, while others quietly crumble on the seabed, exposing their radioactive cores to seawater. Satellite images and daring local explorations reveal a truly post-apocalyptic scene. Rust has eaten through decks and hulls, plants grow where crews once walked, and steel structures decay into the sea. This fleet is not just an environmental liability, but a latent security risk. The sheer number of radioactive, poorly secured nuclear reactors hidden here is staggering, especially just off a city of over 600,000 people. The slow corrosion eats away at barriers meant to contain some of the planet's most dangerous materials. The situation is compounded by whispers of shadowy activities around these wrecks. Some believe the ghost fleet isn't simply neglected, but is being scavenged for parts. Rogue states or terrorist groups might be clandestinely sending divers to strip components like pumps, shielding, or control panels. These parts could be used to build weapons or learn how to dismantle reactors, effectively using rusting relics as live training grounds. If true, this makes the Ghost Fleet a hazardous factory for nuclear terrorism. This bleak scenario is underscored by historical precedent in the region. In August 1985, near Vladivostok, at a shipyard called Chazma Bay, a routine nuclear refueling operation on a Soviet submarine spiraled catastrophically out of control. A chain reaction inside the reactor caused a massive thermal explosion, blasting the 20-ton reactor lid skyward and releasing a radioactive plume over land and sea. 10 sailors died instantly, dozens more were injured, and the area remains contaminated decades later. The Soviet government kept this accident secret for years, and few outside the region know about the small Chernobyl that unfolded there. Official reports blamed a violation of safety procedures, but some suspect it was a reckless experiment testing the limits of reactor performance. The explosion was the worst naval nuclear accident in Soviet history. Not just a failure, but a dangerous decision pushed too far. It left a haunting legacy just feet from the Ghost Fleet's resting place. Today, the submarines rusting in Vladivostok's bays sit directly atop known contamination zones. Local sailors talk in hushed tones about the Ghost Fleet, while satellite photos confirm the wrecks are still there, unmoved and unchecked. International efforts, including funding from the United States and Japan, have helped dismantle many old vessels, but the hardest and most dangerous hulks remain. Each year, corrosion worsens, increasing the chances of reactor collapses and leaks. Unlike some deep-buried Arctic wrecks, the danger here is not sudden or catastrophic, but slow and insidious. Saltwater steadily eats through containment, releasing minute but continuous doses of radioactive poison into a busy fishing harbor. This steady leak threatens the health of marine life, local communities, and regional economies reliant on the sea. The Ghost Fleet is a slow-moving disaster, overshadowed by its own silence. What happens in Vladivostok is a stark reminder that nuclear dangers are not confined to hidden depth or remote Arctic seas. They are rusting just beneath the waves of populated coastlines, real and present. As this Ghost Fleet quietly decays, the risks grow every year, demanding urgent attention and a response that has so far been dangerously overdue. The decay of the Pacific's Ghost Fleet sets the stage for a far different but equally remarkable story, one involving secrets recovered from a Soviet submarine deep beneath the ocean's surface. Secrets salvaged from a Soviet wreck. In the midst of the Cold War, intelligence was as valuable as firepower. One of the most daring underwater exploits took place in 1968 when a Soviet Gulf II-class submarine, the K-129, mysteriously vanished while patrolling the Pacific Ocean. This sub carried 3 nuclear-armed ballistic missiles, making it a potent strategic asset and a prize for any adversary. The Soviets searched extensively but never found it. However, the United States had a secret advantage. The U.S. Navy operated a vast underwater listening network that picked up the sound of the K-129's implosion and estimated its resting place thousands of feet beneath the ocean surface. The submarine rested nearly 3 miles deep, about 16,000 feet, far beyond the reach of divers or conventional salvage equipment. This posed an enormous challenge. How to recover such a massive and heavy object from the ocean floor? The CIA answered with one of the most ambitious covert missions in history, Project Azorian. To conceal the true objective, they partnered with billionaire Howard Hughes, creating a cover story about mining manganese nodules from the ocean floor. Using a massive research ship, the Hughes Glomar Explorer, they deployed an enormous, unorthodox mechanical claw designed to descend 3 miles to grasp the sunken sub. The operation was as secretive as it was groundbreaking. When the giant claw reached the wreckage, it managed to lift about 2/3 of the submarine, but then the claw's damaged grip failed. Much of the sub fell back to the ocean floor. Despite this, the CIA successfully recovered a 40-foot section of the bow, including the remains of 6 Soviet sailors. Beyond bodies, the recovered section contained nuclear-tipped torpedoes, sonar equipment, and top-secret technical manuals representing a treasure trove of intelligence. The sensitive nature of the recovery meant everything was filmed, documented, and closely guarded. The CIA carefully analyzed the recovered equipment, absorbing Soviet technological secrets and potentially neutralizing threats. Yet controversy surrounds what was and wasn't recovered. Soviet sources and independent researchers speculate the mission's official story was a cover-up. One theory claims the Glomar Explorer actually lifted the entire section containing the missile launchers and code rooms, but had to mask this fact due to the sensitive intelligence gained, possibly altering global strategic balances. Another theory suggests the sub wasn't on a routine patrol, but operated by rogue KGB officers planning a covert nuclear strike on Hawaii to frame China, a plan halted only by the sub's sinking. A darker theory implicates an American submarine, the USS Swordfish, indirectly sinking the K-129 during a shadowing mission, turning the CIA's salvage into a frantic scramble to recover lost U.S. technology. In this view, Project Azorian was less about intelligence gathering and more about damage control and hiding a covert attack that nearly ignited a Cold War crisis. These swirling rumors deepen the mystique of the operation. Adding to the intrigue is the origin of a phrase still used by intelligence agencies today: the Glomar response. When journalists exposed Project Azorian, the CIA refused to confirm or deny the mission's details, setting a precedent for secretive replies to sensitive inquiries. This phrase lives on as a hallmark of government secrecy, born from one of the ocean's greatest intelligence gambits. The story of the K-129 reveals that beneath the environmental dangers of Soviet wrecks lies another layer of significance: submerged archives of secrets, technology, and lost lives. These wrecks are more than rust and radiation. They are silent witnesses to a high-stakes Cold War struggle that changed history in ways still rippling beneath the waves. The mysteries uncovered from the depth serve as a stark reminder. The ocean holds both deadly dangers and hidden truths, challenging us to confront not just environmental crises, but shadows from an era defined by conflict and secrecy. Dark theories behind submarine losses. The wrecks scattered across the world's oceans don't just carry technical problems. They harbor dark stories woven from Cold War paranoia and secret experiments. One of the most haunting aspects is the uncertainty surrounding many of the submarine disasters. Official records often cite accidents or technical failures, but whispered theories suggest sabotage, covert collisions, or weapon tests gone wrong. These uncertainties cast long shadows over the true causes of these losses and complicate efforts to grasp the full scale of risks they pose today. Take the Komsomolets as a prime example. Some experts doubt the official account that its devastating fire was sparked by an electrical fault. Instead, speculation points to the submarine testing a new, unstable weapon or fuel type, something volatile enough to ignite and destroy the vessel. Others argue it was the result of a collision with a Western hunter submarine, a silent underwater duel that ended in tragedy. That such a critical piece of naval technology might have been pushed beyond its limit fuels theories of reckless risk-taking during the Cold War. This atmosphere of secrecy isn't limited to accidents. The shadowy legend of Red Mercury adds a layer of mystery to some wreck. Allegedly, a secret Cold War substance used as a nuclear trigger. Its existence remains contested, but some believe experimental torpedoes might have contained it. The strange chemical reactions observed at wreck sites, including aggressive corrosion and high radiation bursts, are sometimes attributed to such unnamed materials. Whether myth or reality, these stories underscore the unknowns lingering beneath the waves. Conspiracy theories also swirl around the sinking of the Soviet submarine K129 in the Pacific. It vanished mysteriously, but some suggest it was sunk intentionally by a U.S. submarine, the USS Swordfish, during close shadowing or even by a deliberate torpedo strike. According to this view, American efforts to recover the submarine were as much about covering up their role in its destruction as spying on Soviet secrets. This tangled web of espionage and subterfuge captures how underwater warfare extended far beyond open battle. Adding to the intrigue, reports from secretive intelligence operations indicate a fierce technological arms race beneath the oceans. The CIA's Project Azorian to salvage the K129 was not just about recovery. It was about reclaiming lost nuclear technology and intelligence in a desperate Cold War maneuver. The Broken Claw story may have been a cover for something more complete and successful, evidence that both superpowers were willing to undertake extraordinary risks to dominate the silent depths. The modern-day ramifications of these lost secrets are disturbing. The wreck, loaded with classified technology and experimental weapons, are now corroding and leaking deadly toxins. No official cleanup effort can address these multi-layered dangers without wrestling with the historical and political sensitivities that still hover around them. The mystery of what exactly lies in these wrecks complicates transparency and makes containment difficult. Some submariners and experts believe that the Cold War itself left behind a legacy of reckless abandonment, treating nuclear vessels not as long-term hazards but as disposable assets. This attitude paved the way for hidden disasters and environmental crises we are only now beginning to understand. The full extent of damage caused by secret tests and hidden sinkings remains a haunting question, shadowed by decades of silence. Understanding the depth of these puzzles leads naturally to the profound impact radiation leaking from these underwater graves has on marine life, and ultimately, humanity itself. The food chain and radioactive fallout. Radioactive leaks from sunken nuclear submarines don't stay on the seafloor. They move through marine ecosystems and ultimately reach human food supplies. Cesium-137, one of the most concerning isotopes, mimics potassium and is readily absorbed by marine life. Plankton take it in first, small fish eat the plankton, and larger predators concentrate the contamination as it ascends the food chain. Eventually, commercially harvested species such as cod and crab may carry traces of radiation, raising concerns for fishing communities. Norwegian scientists monitoring marine life near the Komsomolets wreck have detected cesium-137, though current levels remain within safety limit. But the submarine's corroding hull means leaks are increasing, not diminishing, and long-term radiation loads could eventually reach hazardous threshold. The effects extend beyond fish. Marine mammals, including seals and whales, accumulate radioactive material by feeding on contaminated prey, spreading it across broad migratory routes. This widens the ecological footprint, allowing radiation to reach distant waters far from the original wrecks. Long-lived substances like plutonium heighten the danger. With a half-life of 24,000 years, it lingers in sediments and currents for millennia, ensuring that environmental impacts grow over time and complicating cleanup efforts. Economic consequences are significant as well. Coastal fisheries depend on clean waters. Contamination risks can trigger market losses, safety restrictions, and deep uncertainty for communities whose livelihoods hinge on healthy oceans. Mitigation remains difficult. Ocean currents disperse particles widely, models struggle to track long-term accumulation, and engineering solutions, from lifting wrecks to encasing them on the seafloor, carry major risks and costs. These Cold War legacies reveal how hidden threats can ripple through ecosystems and ultimately reach every shore. From the subtle but persistent contamination in the food chain, attention turns to the urgent race against time to stop these ticking underwater hazards before their consequences become irreparable. Racing against time. Soviet submarine wrecks leaking radiation are not just relics. They are an escalating environmental emergency. After decades of neglect, corrosion is worsening, and toxins are moving deeper into marine ecosystems. Without swift action, contamination will spread through the food chain and into the communities that rely on these waters. A major challenge is how to handle wrecks too deep or fragile to raise. The Komsomolets, resting over 5,500 feet down, is a prime example. Lifting it risks structural collapse and greater leakage. Scientists are therefore considering containment on the seabed. including engineered sarcophagi lowered over wrecks, an underwater equivalent of Chernobyl's protective shelter. Other proposed measures include injecting sealing gels or concrete into hulls to slow radioactive leaks. Though still experimental, these methods aim to stabilize the wrecks without disturbing them. But they require significant funding and carry uncertain results. Shallower wrecks pose dilemmas of their own. The K-159, sunk in 2003 at about 800 feet, could potentially be recovered, but salvage operations risk breaking it apart. Leaving it in place, however, guarantees continued corrosion. Governments and environmental agencies are split between retrieval and long-term containment. International cooperation is essential, yet hindered by politics, limited budgets, and Cold War-era mistrust. Meanwhile, public awareness remains low because these dangers lie out of sight. Scientists, journalists, and activists are pushing to spotlight the issue, hoping to spur action. Advances in robotics and monitoring technologies offer optimism, but the question persists: can we halt these underwater time bombs before the damage becomes irreversible? The legacy of Soviet submarine wrecks is a sobering mix of scientific challenge, environmental urgency, and geopolitical complexity. Now that we know the scale and severity of these underwater dangers, ignoring them is no longer an option. If you found this story eye-opening, please like and subscribe for more revelations about the hidden threats lurking beneath the waves. Your awareness helps bring these crucial issues to the surface.